Yesterday I have made an intro for you, and I've walked through the scheduling part. And for the deep dive session, I'm going to talk about the default and the features and some progress in this project. For me here, my name is Ma Da, and I am the co-leader of the SIG scheduling, and I'm working in Huawei now to work on some resource scheduling. So here's the agenda. There will be a basic agenda. I think you have heard these parts on different occasions, like in Huawei and other companies. So I will walk through this part quickly. And if you are not familiar or particularly interested in this part, after the session we can have further discussions. Then I will talk about the priority and GAN scheduling. So in the Kube batch, this part has been covered a little bit. So I think I will elaborate further on about the GAN scheduling, some notices, and the particular thing we need to pay attention to. Another thing is port scheduling policy. Another thing is the This scheduler.
This scheduler has already been introduced during the intro because this one is very similar to the one GAN scheduler, and this scheduler are introduced here because they are the main features of the deposit scheduler. Other features has not been integrated into the SIG project. They are developed by those who are interested in this in the Google company. So let's have a look at the scheduler. Scheduler is the same as the previous one. And this one is the KubeCon scheduler in the substream. In the package, there's a Kube scheduler, and this is the scheduler we are talking about. In the Kube scheduler, there's an enqueue. The queue will be ordered in the priority. But if it doesn't have any order, it will be respect the rule of the first come first rule. And this node, and we see that which node will mount with which pod, and then if it is connected, and it will be run. And this one is done by the Kubernetes. And the scheduling will not be work with the schedulator, and it just schedule the parts to the node, and it's done. And this is what I have done. API server will just save the latest data, and scheduler will just pull the information, including the pod, nodes, and bugs. If they are in bugs, they will not consider. The pod is assigned to the node, and pod is taken. And here, please pay attention to that. And in the a machine has already been shared and used our record in the scheduler node information in the API is that the account of the pod and the number of the pod will not be changed. And if we get the information of the pod and the node, and then they will calculate in the scheduler, they will know that how many pods and the nodes are idle. For example, if there are a lot of the mod, but from the CLI, you need to calculate it by yourself. There is no one place to tell you that how many pods and nodes are idle. So please pay attention to that. And the default scheduler has already been complained quite a lot. And each time it will just schedule one pod, which means that it will check that which mode is most suitable for the pod. So this is the default scheduling work, and this is the Kubernetes scheduler work, and this kind of the individual scheduler is a kind of the waste to the jobs. So the Kube scheduler or the scheduler are the individual queue, and they will just check the status of the nodes and the pods. And default scheduler choose the pods. There are two aspect. The first one is the predicts, and it says that which kind of the pods and the nodes are available. The one with the cross means that they are not available. So 2, 3, and 4 are useful and are available. But which one should be used and which is the priority? It is done by another features. So this is the priority. And because that's the node 3 has the score of 90, so the pod will be mounted to this node. So this is done by 2 steps. This is how the flow goes, the working flow goes. In this queue, all these kind of the queue are the pendings of the nodes, and you can see that what are the nodes are pending without any pods or without any jobs, because there's a risk considered. If the node name has already been considered, and then the node name will be pending. And in this, the state is pending and or empty. And scheduler will just go through the logic. The logic including two steps, and choose the one with the highest priority. They can choose only one machine. So this is the main thing that the scheduler, what the scheduler is doing. The difference is that maybe the policies for prediction and priorities are different. And I just mentioned that. And finally, if they choose node 3, whose score was 90, and they'll just add it to the server, the pod spot then node name will be changed to the pod 3. And node speller or the pod speller should not be integrated to the Kubernetes. So this is the design policy of the Kubernetes. So when you design your scheduler, please follow this rule. Please follow the rule of the priority. Maybe if there are some changes, and it would be really hard to change it. Another one is label. Label is quite familiar by all of you. For example, what kind of the nodes and what kind of the pods that we should choose. And for the selector, this is what it is. We don't use selector very much. For example, when we choose the node, we don't use the selector very directly because it has already been replaced by the node selector. And we also use the pod selector as well. So as long as you know that there is a function, it's okay. And you are already familiar with this, and after that they will just select the group name, and here we don't use the node very often. In different server, we'll run it on different server. And so let's just have a look at it, and that's all. And I just mentioned that yesterday, the pod must be distributed to different machines. They need to calculate the priority, so they try their best to distribute it to more than one machine. And I just mentioned that the path finality, affinity. And here we have service A, and then the pods will be distributed to the node 1 and node 3. And when the hub, these two will not be together. For about the hub, it has a require, which will result in this kind of the model. One of the model is like this. If we have 3 machines and 3 nodes, but if we have another mode, it won't be shown here. Another mode is the preferred mode. In affinity and anti-affinity, it will be set. It is scheduling or preferred scheduling when it is preferred. The machine means that it may have 2 pods because that they have the highest priority. So when there is the fourth one coming, and then we found that all these 3 are almost the same, and they will definitely choose one, random one. So this is the preferred state. So this is the anti-affinity.
这块说的是 TAN 和 toleration。
And this is about TAN toleration.
最近2个 release 加进来。
And this was added by the latest release. And I would like to give you an example, the memory and the GPU. The memory, GPU means that, for example, there's a pod, and the pod must be deployed to one machine, but it only uses 4G memory. But theoretically, it should be deployed in here, because after this memory has been used, and nobody can use the memory here as well. So this is what they do. And to do the toleration. And if it is deployed to node 1, it doesn't have any memory. Because it has a GPU and has a 4 gigabytes memory, it can be used, it will be full. So what it does is to add a 10, it says that it has a CPU. So if you don't the CPU, you shouldn't be deployed to node 1, and then the pod should be deployed to another machine. And you can see that the memory can meet the requirement, and if it has another pod with the 4 gigabyte memory and 1 GPU, it will be deployed to node 1.
这块的时候，想要放到这块的时候，就是刚才说那理想的时候，这个是怎么做嘛？这个就是需要加一个 toleration。
It needs to add the toleration, and it needs to add the GPU and plus scheduling, so that the toleration will be increased and just schedule it back. Currently, the default achievement, which means that the 10 can be added randomly by yourself. What does that mean? It means that, for example, I have the client, I have a user, as long as I say that I have the authority to operate the node, and I can add the 10. In this way, I just feel that as long as I think that I should use the CPU, nobody can use it. But if I can add the 10, it means that I can allow you to come. For example, the pod has a toleration, so it cannot be used. So it would be deployed to node 1. And later, I would like to give you some more details about which is the node taint policy. It is mainly deal with this kind of the taint and the toleration can be added arbitrarily, because it can provide somebody to occupy some machines, and then others of the machines will be idle. So we need a manager to balance the usage of the different machines and the different nodes. And here I would like to talk about the priority and the preemption. And this is the 1.10 version. It has already been available in the 1.10 version, but currently we have already released the beta version. And the main case is like this. We have a pod. The pod may be a very important one, but all the machine has already been occupied. So there is no way to schedule the important pod to add a machine. So what we are doing is, in another case, it hopes that
这块就是加这个 priority class。
And this one, we add the priority class to it, make it is higher in the level regarding to the priority. We have 3 colors. The red means that's high priority, and the yellow one is the mid priority, and the green one is the low priority. When there is a red one, they will like to check the nodes on the 3 machines. When it checks, it has different parameters. The first one is that whether it has sufficient as well, and the second one, don't break the pod affinity and the PDB, because it has already been ranked and it has its own priority. So they would like to find the corresponding information and to deploy it to the corresponding position. In this picture, it would like to choose it from the lowest priority one. For example, there are some discussion. If you choose the lowest priority, they need to choose from the lowest one. Otherwise, if the higher priority has already been removed, and they need to be rescheduled again, so we need to have to deploy it and replace the lowest priority one. So beside the priority, and also consider the affinity. They don't want to break the affinity.
This
is the current feature. And later it will work on this. This is the preemption and the priorities basic features. And here, actually, some notice. Here are some things, special things we need to pay attention to. First, for this priority in the queue, as we know, before scheduling, there is pending queue, and in this queue, there is also arranged, ordered by priority as well. So when you check the result, you need to be aware that because API server, in the development, it involves components such as API server, controller, and scheduler. There may be risk connection between them. In other words, when your scheduler is considering the pending queue and similar tasks, it will only consider current snapshot. So it may that when you run the check, it may select the medium priority pod first and then seize the high priority pod later. It's possible because it's not completely synchronized. So when you have the additional preemption, you need to pay attention. It can be a bug. Or sometimes because of the scheduler can only get the current snapshot and made the decision based on that snapshot. Therefore, you need to pay attention to that when you see this. You need to check the log or the monitor to check the status. So this is much about priority and preemption. Now these two are enabled in beta, starting from 1.2 to 1.3. So now, if it is lifted to 1.2, it means by default the priority and preemption are existed. For preemption and the priority, these should be considered as two separate things, meaning that preemption means that when I think the machine A gets extra resource, when pod A, or if A has the higher priority than B, then it can seize B's resources. Now we have the pipeline, and now we are working on a priority as a pipeline A. So now what I can think of is for the two kind of preemption. First is I set the hardcode priority. Second is when I use the job or use the pod group. When I found that A gets more resources than B, then B should be able to seize the resources because the both should have resources half and half. But now one gets 60, the other gets 40. Then the one who gets 40 should be able to seize the resource. So priority is not the ultimate indicator. Now we are working on this direction, or we're thinking about doing this. So when you make your own scheduler, maybe you can try it as well. Now for the gang scheduling, there's a lot of discussion about it. What does it do for gang scheduling? It means that the cluster size is fixed by default. Like on the cloud, you think the cloud is limitless. We will exclude such scenario. Even if you really run the cloud limitless, there is cost issue. Now for gang scheduling, in this machine, these pods needs to run. Like the TenFlow and others, these jobs need to run together. So that the tasks can be all completed, otherwise they will wait for each other. In the worst scenario, when the order of the pod is changed, there may be some changes, meaning that some jobs, only some jobs run and others stay idle. That means the green tasks are waiting for the start. For the green pod is for the green pod to start. That would cause resource waste. Of course, you can find a way like a timeout to fix it. Like after 1 minute they don't start, then you can restart it or rerun it. But still, the same problem may occur. So we use some enhanced feature for gang scheduler so that all jobs can run together. But when we try to work on it, we realized we need to consider a lot of cases. For example, here, I don't know if you can see it here. This is light blue. These parts are light blue. That means that when we run Sparks or train jobs, there is a master and a worker node. So not every job is the same. And here these parts, there may be MPI worker and a plan together. And here, there may be one or two master and several workers. So master and a worker may not be the same image, and their pod may be different. For example, in the TN job, they are different here. Therefore, we are required to make them compatible to consider them. Otherwise, they won't be able to run together. In order to make them compatible, we introduce a thing called a pod group. So this is the pod group. At the beginning, we wanted to call it job, but job has the badge. You can find something also called a job in another plugin. So we call it pod group. And the definition is at a finalized stage. And here, you can find a tolerance resource. I will talk about it later. There it says later. So how does it work? Not sure if you can see clearly. I will explain it. From here, to the bottom, to the part before the red box. It is a native badge from YAML file, and in the red box we add a connotation scheduling K8s.io, the group name. And here, there's a group name, we call it QJ1. And what you see here is the existing format. And for the bottom red box, it's CRD, which is called a pod group. The definition of the pod group. As I said here, there's a name. As long as these two names are matched in the scheduling, it would be regarded as one pod created. In this way, you can actually create multiple jobs or jobs plus RCE. As long as your connotation of the group name is consistent, is the same, it will belong to the one pod group. And in the pod group, it will have a min member. The min member are what I said, these six members, and you can set as 6 in the scheduling. That means in the scheduling, when we have the 6 members, then it will be scheduled. This is what gang scheduling does. And here is additional extension. From the left, you can see min member is 8. And on the right, min member is 6. What does it mean? For MPI task, the task flow or train job falls on such model, meaning the pending pod are the same as the pod to be run in the future. But for the Sparks, the extra 2 would be nice to have, meaning that the Sparks can run the 5 executor and the remaining 2 are nice to have. You can run it or not run it, that's fine. We support both model. But here, what do we do? How can we deal with the remaining two pod? Because these two, when you have multiple tasks, and these two would work on sharing, use the sharing by percentage, and the previous six ones to maintain the gun scheduling. So basically, gun scheduling runs through min member, which is quite simple. As long as you get the enough resource, then you can run it. What I said before is things done in gun scheduling, but one problem is that you can't guarantee that all these quota is unlimited. Also, for the same task, the tricky thing is that the quota block the tasks, and the quota size can meet the requirement. You are not able to create extra pending pod. So scheduler, at this point, we can't do anything. We can do nothing. Because if you set min member as 8 and the above as 6, you can't schedule it. And here, for this part, because the quota size is full, and it won't create pending pods anymore. There are several ways to just... At the beginning, you can set a bigger quota, then it will fix the problem to accommodate all the pods. You can just set the quota and set the quota big enough. But one problem is if there is too many pods, it will affect the APM server and the efficiency. Also, when it creates too many things, the quota would be meaningless. But we still want to add a quota. So we have some discussions, and we decided that for the total resource I mentioned, we will make an enhancement. Make quota as a reserve. For example, we mentioned about the pod group. When the pod group has this total resource, and the resource will be reserved. So when the next time you create the automation will come, and that means we make a reservation at the pod, so that we can avoid the case that. And we will wait all the resources are in place, that we will create the pod. So this is what we need to do for the enhancement later in the future. So far, we haven't realized this total resource yet. Another thing is about life cycle. For the sparks, it's easier to do because when you kill it, you restart it, there is no connection between the new one and the old one. But the tricky thing here is for the training job or NPI job, when you kill it, you have to restart the whole task. In the existing controller, there is no feature like this. For example, for the RCE, it will restart individual pod instead of the whole thing. So there is no feature to support this yet. Therefore, in the future running, we will add the relevant policy and the pod group controller. For example, when one pod is killed, the whole task shall the task be restarted or just one pod restarted.
Another aspect is that the controller cares nothing. And on default, and it can be responsible for something. So what would you like to do? And you will have a controller on the other layer to control the life cycle. It is quite complicated. If you are not satisfied, and you can create your one, but actually we need to support two cases. One is that reboost the whole job, and the another one is just reboost the individual one. And if you would like to, if you don't want to use the scheduler and just set it on ignore in the default, for the scheduling, and the following batch will be implemented in the Kube batch. In future, how we should deploy this default scheduler, and we will discuss it. And we have a quite slow framework, which is the scheduler framework. We may base on that, and we may do that on a brand new framework, and we haven't decided yet. Another one is scheduler policy. Scheduling policy, I will just talk about the pods and the taint, and all these will affect the productivity of the resources. Anything you can use, anything you don't use. And sometimes we hope that we have all the resources, we can use it by randomly, but we need to have the restriction exactly for the specific applications which are namespace scope into the contained node. And we also have other things that require restriction, usage of some policy classes, and voice code affinity or anti-affinity rules on some particular namespace. And policy, we can have more policies. The higher level policy match, or it can carry out and it will work. And if it doesn't work, and the later one will go up. And we have the selectors. If they match, and we'll see that whether we pass it or we have to reject it. The main idea is to control, to make sure that the policy should be controlled by the operator. We shouldn't get more resources from some external hacks. And this is what we are looking for. And I have two cases here. And I think that you are quite familiar with that, so I would like to skip that, except telling you that I have some question marks here, because the YAML file has not been finalized completely. Therefore, if you would like to use it, and you need to use it from the community, and the later one is the scheduling policy will be left out of free under the Kubernetes SIG org doc, and it will use a CRD-based approach. And still under discussion because it is a really important project, and the policy working group is still cooperate with other projects of the Microsoft and see that whether we can cooperate with others. So a lot of things are under discussion. I hope that you can chase and follow up the latest data of this project. And if something has already been completed, and we will terminate it. And this one is the policy is done by the policy working group. And the SIG scheduling, the working group will provide some basic features of the policy, and the SIG scheduler will decide that whether they would like to use these basic features to restrict the taint and affinity, etc. No matter it is the taint or the something, there will be the restriction on the scheduler. And the last one is quite similar to the one in the intro part. And what we need to do is the pod migration. No matter it's the Kube batch or the same, they are not doing the pod migration. For the Kube patch, it will including this part because it will be responsible the whole information in the cluster. But what they need to do is to evacuate and then create a new one and then reschedule by using the rescheduler. And all these are some cases, some change of the nodes because they had already running for a long time. So the status of the nodes or the pods are not meeting the default state of the scheduler. And all these are the sub policies. Node affinity, or if there are a lot of the pods on this node and the rescheduler would like to rebalance it. And there are some restrictions. For example, pod associate will the dump set, and the pods with the local storage are now effective. And the best effort pods are effective before the burst stable and the guaranteed pods. for the daemon set, if it is evacuated, it have to be recreated, and pods are never evacuated if it violates its PDB, because if it violates the PDB, it doesn't work. Okay, so much from me. And I also have the WeChat group. All the members of the WeChat group are the developers of the schedulers. You can scan the QR code and join the group. And this one from the Baidu, and this one from Ali, and I also in this group. And we also have a group from the Tucson. So if you are interested, and you can join this group and talk about the developing of the scheduler with us. And so much from me. So, do we still have any time for Q&A? Yeah, actually, you already used all the time slots you should have. So, but if you need to have the Q&A session, you can have it as well. Okay, in that case, so let's call it today. And if you have any questions, and feel free to contact me. Thank you.